Section 2.2 is about linear equations, equations of a line, equations that create lines. Definition of a linear equation is an equation whose graph is a line. And then here you see some things that make up linear equations and things that don't. Linear equations can have addition in them, subtraction. They can have multiplication of a variable by a constant, which means you can only multiply by a number. Now actually you can divide, multiplication or division, but it has to be by a number, not a variable. What you cannot have is variables multiplied together. You cannot have variables in the denominator, in other words, division of variables. And you can't have exponents other than 1, squares, cubes to the 4th power. You can't have those if you want them to be linear. Here you see some examples of linear equations. They all fit this criteria. These are all linear, but they're written in different ways. Here are examples of ones that are not linear. This one's not linear because it has a square. This one because it has a square root. Here you're multiplying variables, which you can't do, and here you're dividing by a variable. So all these are not linear equations. Here you have a definition of a linear function. It's the same as a linear equation. It's just written in function notation, and that ordered pairs will satisfy it. If you remember, this is slope-intercept form, which we've typically seen as y equals mx plus b. Here we're just writing it in function notation using f of x instead of y. So let's state whether each of these functions is linear or not, and then we can explain. First one, f of x equals 10 minus 5x. Well, if I were to just rewrite this by putting the 5x or the negative 5x first and then putting plus 10, which is legal, then that certainly is a linear function, because you can see that the m is negative 5, the slope is negative 5, and the b, the y-intercept, equals 10. So this is a linear function. This one looks like it's in the form. The only problem is it has an exponent of 4. So we would say that this is not a linear function, and it has an exponent other than 1. Our last one, it says equals 2x. Well, I don't see a plus b, which is not a problem. B could be a 0. But the more important thing is I'm multiplying by variables, and you can't do that. So this is not a function, because I have two variables that are multiplied together. Here you have an example of where you might use a linear function. A linear model is sometimes what we call this as well. It talks about a Russian submarine sank 350 feet in Barents Sea. This is the linear function that represents it. So P of D. Now since capital P is the pressure, that means the pressure when you know a depth. That's what P of D means. Equals 62.5 D, and D is our depth, and that's plus 2117. So that's my function, my model for this situation. Now we want to find the pressure, we want to find the P at depth 350. So all we do is we take the D and replace it with 350, and we can find the pressure at that depth. So if you plug that into a calculator, you're going to get 23,992. That's my pressure, and it's going to be labeled as pounds per square feet, because that's how pressure is labeled in this particular problem. How do I know? It's right there. Here we're going to look at the standard form of a linear equation. You may recognize standard form as ax plus by equals c. A couple things about the a, b, and c. Those are nothing more than numbers. The x and y are the only variables in this form. A, b, and c are just numbers. Now one thing you have to know, a is greater than 0, which means we always want the a to be positive. We don't ever want a negative a value. That keeps all of our answers uniform, so we can all be talking about the same thing. Also, a and b cannot be 0, cannot both be 0. And one thing that they don't say here, a, b, and c should be integers. We typically want standard form to exist without fractions or decimals. We'd like integers. So we want to write each equation here in standard form and then figure out what the a, b, and c is. So we'll look down here. This first example is written in slope-intercept form. So if I were to take this 2x and add it to both sides, I would end up getting a 2x plus a y on the left. Now you can't combine those, they're not like terms, so don't think it's 2xy or something like that. And that equals 3. So this is now in standard form. ax plus by equals c. And we can say that my a is 2. And then what would my b be? If there's no number in front of the y, we assume there's a 1. And then my c would equal 3. So this is standard form, and this is what a, b, and c equal. Let's come over to the next one. The first thing that I notice when I look at this is I see a fraction. And I told you that a, b, and c have to be integers. So I want to try to get rid of this fraction. So how do we get rid of denominators? If you remember, we multiply every term by the denominator. And that's legal to do because I'm keeping the scales balanced. And when I multiply a 5 on top and I have a division of 5 on the bottom, those will cancel, leaving me with a negative 3x. Here I have a 5 and a 3 that are both on top, so I multiply them, 15y, and that's minus 10. So I've taken care of my fraction problem. I now need to get this so the a and b are on the same side with the c on the other side. A couple ways you could do this. We could add 3x and move it over to the right. Or some people would just look and say, hey, the y needs to come to the left, so I'm going to subtract it. So we get negative 3x minus 15y, and that equals negative 10. Now this would be in standard form, except my a is not greater than 0. So I've got to divide by negative 1 or multiply everything by negative 1 because I want to change all the signs. I want this to be positive. So negative divided by a negative is a positive. Negative divided by a negative is also a positive. And here negative divided by a negative is another positive. So that's what it looks like in standard form. We've now finished that part. It's fairly easy to then see our a is a 3, our b is a 15, and our c is a 10. Last example. It looks pretty close to standard form. The only problem is it has this minus 9 here, so I'm going to add that to both sides. So 3x minus 6y equals 9. There's one other thing that you probably learned back in algebra that we haven't mentioned here, and that's why I'm showing you this example. If you notice all three of these coefficients, if you will, or the a, b, and c, they all share a common factor. They can all be reduced by a factor of 3. So if I divide everything by 3, I can cancel here and make it a 1x. I can cancel here and make it a 2y. And I can cancel here and make it a 3. And you typically want your standard forms to be in lowest terms. So we divide out a common factor, and now we look for a, b, and c. A is a 1, b is a negative 2, because the sign belongs with the 2, and c is 3. Last thing we'll talk about here is x and y intercept. X-intercept is the x-coordinate of a point where the line crosses the x-axis. And the y-intercept is the y-coordinate of a point where it crosses the y-axis. You can find the x-intercept by plugging in 0 for y, and vice versa. You can find the y-intercept by plugging in 0 for x. So here we have a graph, or an equation that we can graph, 3x minus 4y plus 12 equals 0. And we're going to find that graph by plugging in zeros and finding the x and y intercept. So let's first look for the x-intercept. How do we do that? We plug a 0 in for y. So I'm going to take my y and put a 0 in its place. And then I'm going to solve. So 3x plus 12 equals 0. Subtract 12. So 3x equals negative 12. And then divide by 3. So it looks like x equals negative 4. That means when I plug a 0 in for my y, I got a negative 4 for my x. So that is my x-intercept. That's how you find it. Now we'll find my y-intercept. And the way we do that is we plug 0 in for the x value, and we solve for y. So 3 times 0 is 0. I'm going to subtract 12, so negative 4y equals negative 12. And then divide by negative 4. So y equals positive 3, which means when I plug a 0 in for x, I got a positive 3 for y. So these are my two intercepts. My x-intercept is negative 4, 0. Notice the 0, y coordinate. And my y-intercept is 0, 3. Notice the 0, x coordinate. I'm going to graph those. Negative 4, 0 is right here. 0, 3 is right here. And that's what my graph looks like with my y-intercept and my x-intercept.